differential calculus. I don't know, maybe I'm seeing it in dream. Maybe some people are bringing them to me. But I'm telling you, you will encounter these problems. But you'll be able to solve them. One, I want to make sure we are able to establish the first principle. I hope we're able to use the first principle. Don't worry. The chain rule can definitely not be left. Differentiation at all. So let's talk about the two first. And let's see if we can talk about the Euler's theorem as well. You can mute your mic, please. So let's start with the chain rule. Mute your mic, please. The chain rule is one of the techniques used in differentiating. If I'm given y equal to sine 2x, 2x is already a function of x, that is multiplying x by 2. Now another function now enters the function of x, that is the sine of 2x. This is a composite function. It is a function of a function. That means I'm going to use the chain rule in this case. To use the chain rule now, I have the formula. The formula now, I'm sure for those of you that did your TMS yourself, you will remember vividly that you encountered this problem, that it said which one is the correct formula for the chain rule. dy dx is equal to dy du times du dx. So calculus is not, dy dx is not about fraction, but I can tell you to just take it as a trick. If I cancel my du now, you'll see that it remains only dy dx. That means dy dx is still the same as dy dx. So you can write dy du times the x du. Don't go and make that kind of mistake. Because there is no way this one can cancel each other and you'll be having dy dx back. Or if it is dy du times du dx, it is very, very possible. So what will be my u? My u will be this. U is equal to 2x. That's going to be the function that is inside. And my y is going to be what? Sine. Instead of writing the 2x, I'll now say sine u. So dy dx now, very simple, is equal to dy du. What is dy du? That means dy du means the derivative of sine u. What is the derivative of sine u? Anyone, please? The derivative of sine u is, because of time, cosine u. If the derivative of sine x is cosine x, so the derivative of sine u is definitely cosine u. No form of confusion at all. You should not be confused at all. So that's going to be dy du is cosine u times du dx. What is du dx? U is equal to 2x. So du dx is definitely going to be 2, Abi?
Yes.
And I'm sure you can remember that. So 2. So what I have now is 2 times cosine u is what? 2x. You see this long method? It's things that can be done within 2 seconds, 1 second. It depends on your ability to practice. I can't believe anyone. So here is another question that comes out in the TMA very well. Note this formula very well. It might just be a question. You write dy du times du dx, dy du plus du dx, dy du times dx du. Which one is correct? It is dy du times du dx. So this one is e raised to power sine 2x. E raised to power sine x, was it something like this? Equals to y. What is dy dx? We know that sine x is already a function. Now, e is raised to the power of sine x again. That is a function raised to the power of a function. That is a function of another function. Use the chain rule again. dy dx is equal to dy du times du dx. So my u is going to be sine x, and the u dx means what? The derivative of sine x is cosine x. And my y now is obviously e raised to power sine x, which is u. It's a pity we can't start calculus, but that's when it's easier to understand. So y is equal to e raised to power u. Then dy du is also equal to e raised to power u. This is the only function that doesn't change. So, what's this, please? What is it?
Sorry, the derivative of sine x, I thought should be minus cosine now.
I know you. Don't forget calculus. And cosine x. It is the derivative of cosine x that is minus sine x. It is the derivative of cosine x that is minus sine x.
Please, Mr. Ali, go on. That guy don't chop chicken, drink malt. Please go on.
So, e raised to power u, derivative of e raised to power anything, e raised to power u, I say, is still going to be e raised to power u if that is not a composite function. So now, we can now find the y dx by saying dy du. What is my dy du? That is e raised to power u times du dx, that is cosine x. That means it is now cosine x times e raised to power, what is u? Sine x. This is a question that came in different people's theorems. Yes, this exact question. And this is the exact answer. So that is chain rule. The first thing I would like you to note very well is this formula. The second thing is know this question. Like just know the answers. You might be lucky to encounter it. It is a TMA question. So implicit differentiation is what I want us to concentrate on, because I'm sure you will encounter it too. Implicit differentiation. That is when I'm differentiating not only with respect to x, but rather with respect to y and x. This is a function. 3x squared plus 7xy plus 8y squared plus 7xy equals 0. Joy and Prodigy can please. You can remember it better. Share about it. This is a relationship now, or some kind of equation. What is the derivative? Differentiate with respect to x. That means anything that is different from x here, I'm going to be treating it as a constant first. Be with me. I'm still going to explain partial derivative. But let's go small. This is 3x squared. Differentiate 3x squared. Someone, please. Differentiate 3x squared.
6x.
Okay. For those of you that are unable to know what it is, that is 2 times 3, that's 6. And this x raised to power the 2 minus 1, that's 1. So 6x raised to power 1, which is the same as 6x. Plus, now we want to differentiate 7xy. First, we have to keep y a constant. Make y a constant. Treat y as if it is just a number. The second, we treat x as if it is just a number. So this is it. treating y as if it is just a number, derivative of 7xy is going to be what? 7y. Do you agree with me? I don't want only one person to agree with me.
We are with you.
Yeah, I'm trying to see if everyone got it. That's what I mean.
Yeah.
If everyone got it, I don't want anyone to be left behind. Okay, that being the case, we are able to, I said we are treating y as if it is just a number. So let's say it is just like 3. So 7 times 3. You know the x will definitely be eliminated since it's being differentiated with respect to. Then plus, now treat y. Treat x now as if it is what? Treat x now, this x. Treat x as if it is a constant. Differentiate with respect to y. That means I'm going to be having 7x. Abi? If I'm going to treat which person? Everyone, please just a minute. A minute. Just a minute, sorry. It's nonsense. Okay. So, explain how many English? Okay. So 6x plus 7y plus 7x. We said we want to we differentiated with respect to x now. And let us differentiate with respect to y. That is, we'll be treating x as a constant. So I'm having 7x. But how will I know this one differently from this one? I'm differentiating with y here. That means I must put the y, the x, plus 8y squared. Differentiate 8y squared. That's going to be 2 times 8, 16. So 16y raised to power 1, right? 16y. But what did I differentiate with respect? I must still put the y, the x. Anywhere I'm differentiating with respect to y, I must put my dy dx here. Plus, so 7xy now. Let me differentiate with respect to x first. That will be 7y, right? I'm treating y as a constant. Plus, so implicit differentiation is a form of total derivative. 7y plus 7xy now. Differentiate with respect to y. That's going to be what? Let's assume it is equal to 8. That's going to be 7x, right? I'm treating x as a constant. But it is differentiated in respect to y. That's the y dx. Don't worry, I'll use a simpler thing to do the next example. Is equal to, the derivative of 8 is what? Is a constant, so the derivative is 0. So this gives me 6x plus 7y plus, this is 6x, 7y plus this 7y is equal to, I have to bring everything that has the y dx to one side. So 7x from plus 7x here to the other side, it becomes minus 7x minus 16y sorry, minus 7x dy dx. Let's be going step by step. Minus 16y dy dx and minus 7x dy dx again. So this is 6x plus 7y plus 7y, 14y is equal to minus 7x dy dx minus 7x dy dx. That's minus 14x dy dx minus 16y dy dx. Now you bring dy dx out as a common parameter. So this is going to be equal to minus 14x dy minus 14x minus 16y dy dx is equal to 6x plus 14y. Now I have dy dx here. Let me divide both sides by minus 14x minus 16y. So dy dx is equal to 6x plus 14y all over minus 14x minus 16y. So if you bring 2 out here, I don't want to simplify them. So this also makes sense as an answer. You can put this down. I will use a simpler thing to explain next.
So is that the final answer?
Take it as the final answer. If you don't want to take it as the final answer, then bring 2 out. I'll be having 3x plus 7y all over 2 out. I'll be having minus 7x minus 8y. 2 cancels 2. So we can take this as the final answer. Minus 3x plus 7y all over 7x plus 8y.
Because why I'm asking, if this thing is filling the gap like this, if you do anyhow, now go fail you.
No, this one cannot be filling the gap. No, it will not be filling the gap.
No, try those people. Their head no correct.
I pray for you. I pray. You try your best now. May God help you. You are different from someone that didn't study at all. Try your best. Don't worry, you'll be favored, and I'll be favored.
Okay, sure, the shortcut.
Let's do another one. We should put this down. I'll use a simpler stuff. It won't be hard. Don't worry, don't intimidate yourselves.
Now that's the thing what.
Okay, write this down. Let's use a simpler stuff to do the example. Okay, I'm going to run this up and proceed. Okay, so now this is a simple one. X squared plus 4xy plus y squared is equal to 18. So let us differentiate this thing. Whenever it is involving x and y, in fact, you might be asked, it is a type of implicit differentiation. I'm not differentiating explicit. So x squared, differentiate x squared, that's going to be 2x simply, plus 4xy must be differentiated into 2 forms. The first is with respect to x, the second is with respect to y. So I'm going to change my 4xy to 4x squared y squared to make it more complex. 4x squared y squared. So now differentiate 4x squared y squared with respect to x. That means I'm going to treat y as a constant. So that's going to be the 2 that is on top, this x, multiplied by 4, that is 8, and y squared is here, y squared, and the x will be raised to power 2 minus 1. So I have 8y squared x plus
Pardon, I'm not with you.
Okay. We'll give it me. Just give me a few minutes. So 4 is here, right? Y squared is here. We are treating these things as constants. It will be x squared left. Now differentiate the x squared there. That's going to be 2x. Now multiply the 2 by 4. That's going to be 8x. Don't forget. So 8x y squared. Plus, you understand it again now. Differentiate this thing with respect to y. That means you are treating the whole of this as a constant. Yeah, if it is a constant, nothing will do it. Just write it out. 4x squared. Now differentiate that y squared. Y squared differentiated will be what? 2y. So your y is here and times 2. So 2 times 4, 8. Without trying this thing, it is still not understanding if you don't try it. But this one is differentiated with respect to y. So I have to put the y, the x. Plus y squared. Differentiate y squared. That is 2y. Then the y, the x is equal to differentiate 18, 0. So this is now 2x plus 8xy squared is equal to minus 8x squared y dy dx minus 2y dy dx. The thing from plus 2y goes to the other side becomes minus 2. From plus 2y, from plus 8x squared. So we can now have 2x plus 8xy squared is equal to minus 8x squared y minus 2y, open bracket, dy dx. Now divide both sides by this thing. I'll be having my dy dx to be equal to 2x plus 8y squared all over minus 8x squared minus 2y. What's its place?
What about the 18 on the right hand side?
Where is it? 18 has been differentiated to give us 0.
Constant.
It's a constant, thank you. So the derivative of a constant is 0. It has been differentiated. So the final answer of this one is going to be x plus 4y squared. That is by dividing through by 2. All over minus 4x squared y minus y. So that's the implicit differentiation value. I explained this last semester too. The thing is about knowing one or two differentiations. I'm going to stop here. Partial differentiation, partial derivatives. Partial derivatives. But I will employ you very well. We did everything concerning series. Take your time to read the material. Read. I wish everyone the best. They are not hard stuff. Just read. Now you know what read. So if I wrote this thing, dy dx, it is different from dy dx, and it is different from dy dx. This is the normal derivative. This is increment in y over increment in x. We call this infinitesimal derivative, and this is partial derivative. Partial derivative.
Please come again.
This is infinitesimal. This is actual derivative or normal derivative. And this is partial derivative. There are 3 different letters. I'm going to show you what I mean now. This is a function. Y is equal to, let me use f. F is a function of x and is a function of y. That's the meaning of f of x, y. F of x means f is a function of x. But now f of x, y means f is a function of x, at the same time is a function of y, is equal to x squared plus y squared. Now find the f, the x. Look at what I did here. Look at what I wrote. It is different from the f, the x. The f, the x here is partial derivative of f with respect to x. That means I'm going to treat y as a constant in this case. I'm going to treat y as a what? As a constant. Now,
I'm not with you.
Okay. This thing is very important. Look at it very well. This d that I wrote. It is different from this d. This is delta, small letter delta. This is partial derivative. This d. This is the d. Now, f is a function of x. Joy, what's it, please? I'm explaining it again, though. What was it?
Sorry, I raised my hand before. I did not lower it.
F of x over y means f is a function of x and y. And this is it. We can see that f is a function of x. At the same time, it's a function of y. So what is the df, the partial derivative of x, f with respect to x? That means you will forget the fact that y squared is a variable. You treat it as a constant straight away. You treat it as a what? Constant. This one is not implicit differentiation again. You treat it as a constant parameter. It's not like you come and differentiate it later. No. Treat it as a constant. So df the x is going to be 2x. That means you are treating y as a constant. Look at how it is written. Y as a constant. Now, what if it is df dy you are looking for? Treating x as a constant. That means it is going to be what? 2y. X as a constant. The derivative of a constant means 0. Someone just said it now. If you were treating your y as a constant, that means its derivative is 0. That's why you have 2x plus 0, which is equal to 2x. Now, if you were treating your x as a constant, according to what you have here, that means your derivative of x squared will be 0, then added to the derivative of y squared, which is 2y, and that's equal to 2y. Now, if this is my f, which is a function of x and y, is equal to 2x squared plus 3x y plus y squared. Find dy df with x constant and find find df y with x constant and find df dx with y constant. When x is constant, that is the partial derivative. Partial derivative means you are differentiating partially. You are differentiating a part and you are leaving a part as a constant. It is different from implicit differentiation. It is the opposite of total differentiation. So partial differentiation is now like this. 2x squared. You are differentiating with respect to y, making x a constant. So differentiate this whole constant, 0. Please, if you got what I just did now, show with your reaction. I can definitely explain it again because I'm ending it here.
I did not get it.
Okay. I said this is the f dy. This x written down here means you are making x a constant. So in this thing now, the f dy making x a constant means whenever you have x, the derivative is 0. So the derivative of everything here, since they are all constant, is what? 0. Plus 3xy. You are making x a constant, differentiating with respect to y. Differentiate 3xy. So 3x is a constant. You'll be left with 3x plus differentiate y squared. That's 2y. So the answer is 3x plus 2y. Now look at that of y to understand it better. I'm differentiating f with respect to x. I'm going to neglect y. I'm going to make it a constant. So this is the first thing I have there. Differentiate 2x squared. That is 4x plus differentiate 3xy when y is a constant. That's going to be what? What's it, bro? What did you?
I thought it should be 0 plus 3y here. That's what the x supposed to be the constant there.
Since x is a constant, we are differentiating y. Did you not get it? This is it, 3xy. 3x as the constant, assume it is 6, so 36y. If I'm differentiating 36y, what's the answer? 36. Y will remove. So if I'm differentiating 3xy, I'll have 3x. Y will remove. Y will move. Move. Did not still get it after moving. So now I have 4x
Maybe so with 3y.
plus 3.
3y. 3y.
3y. My y as a constant now. It's very simple. Just assume your y is one number, like 6. So just write your number 3. Because if you have 3x and 6, or like 3, 6x, you can't differentiate this without having 6 as the answer. So just take 3y answer here. Plus y squared is 0, because we are differentiating with respect to x, taking y as a constant. This is what we mean by partial derivative. We are differentiating with 1 and we are making 1 a constant. I'll give another example which I'm going to end it with. What's your question, please?
Okay, my question is like this. When you are treating y, you differentiated that 3y. Why don't you differentiate 3x when you are treating x?
I differentiated it. Look at the bottom. Look at the bottom. I'm sure you will see that. F of x comma y is now 3x squared plus 5y squared. Find df dx when y is constant. This is equal to when y is constant. Treat your y as a constant, just as a number. Assume I have 3. You can rearrange it by yourself and write it as 3yx squared. It is still the same thing. Now assume y is a constant, like 36x squared. Don't forget that your y is not 6, so assume it is a constant. Now to differentiate this, what will you have? 2 times 3, 6. So 6, and this is there already. But don't forget that 6 is just y. So 6y, x raised to power 2 minus 1. That's x raised to 2. You've differentiated this one. You treated y as a constant, and it is still a constant. Nothing happened. Plus 4x squared, very close, right? That is 8x. Plus 5y squared, 0. You treated y as a constant. Here, the f y now, x as a constant. The f dy now is equal to treating x as a constant. You can look at your word again, rewrite it as 3x squared y. Treating x as a constant. That means it can be the same as 3, 6 squared y. So if you differentiate this, what are you having? The y will just be living there. You will be left with only 1. So that is 3y, but there is a squared. I think I still have to take one more example. Plus, differentiate 4x squared. When x is constant, that's 0. Plus, differentiate 5y squared. Now, that is 10y. The last example before I leave this please. F of x comma y is equal to 7x squared minus 7y squared minus 7x squared y squared. So f of x comma y is equal to 7x squared now. Okay. The y, the x, the x, when y is a constant, is equal to 14x. I'm sure everyone agrees with me on this. Minus 0 minus, now I'm differentiating, making y a constant. So assume your y is a number. Rearrange it as 7y squared x squared first. Now assume it is a number. Like what? Like 6. 7, 6 squared x squared. Don't forget it is not a number. So just do 2 times 7, 14. And your 6 squared is still 6 squared. But remember your 6 is y squared. And x is no more raised to power 2 now because you choose x. So that means it is 14x minus 14y squared x when y is constant. Now differentiate f with respect to y when x is constant. Still the same, just the values change. The variable interchange. So this is going to be 7x squared will be 0 minus 7y squared will be 14y minus x squared is at the front, right? So just treat it as 7.
Yeah, but using my network.
Oh, this.
Network don't come again.
Ali, we can hear you.
Telling me nobody. Mrs. Joy. Joy.
Yes, yes.
Chat him up immediately. Tell him his network is flickering.
Yes, I just chatted him now.
Okay.
I've chatted him.
So as he was explaining, guys, he's just trying to make you understand this implicit differentiation. So anytime you are differentiating y, you assume that x is constant and you don't do anything to it, right? Joy, am I right?
You say what, please? Every time what?
Anytime you have to differentiate y in an implicit differentiation, you just assume that x is
Yes.
constant. So you don't do anything to that x. You just leave it the way it is and you differentiate y.
Yes, according to this.
Yes.
Yeah, according to the explanation.
Then after you differentiated
Yes.
it, because it's y that you differentiated, you must it now carries the y dx on it.
Yes.
Then
That's
after
right.
that, you now differentiate the x and you assume that the y is constant. So after differentiating the x, you don't need to put the y dx because y was not the function there, rather x. So I don't know if you get it or is there anybody still confused? No one is talking. Oh.
Please, hello.
We are all agreed according to the explanation.
Okay. Amina. Amina.
Yes, Mr. King, good evening. Longest time. Happy New Year.
Good day. What's up now? So what do you want
Please,
to discuss?
I will need the
Call him on
note,
normal
so
phone.
please.
You will need.
The
He
normal.
said it's coming.
Please,
No,
I
you will
need
need the
the.
recording.
Okay,
Yeah,
no,
of
Allah.
course. You will get the recording now. The recording is always at the group then. The links is always at the group. Once you have the link, you can
He's
go
back
to it.
now.
Okay, so in the absence of any question, I think Ali is back.
But one comment Joe, it will be the absence of any question. And then we don't end class, Charlie. In the presence of any question, I mean, everyone. I finished, and I thought we were taking another class. I still have classes to do. Just
Just that last
let's do
explanation.
this.
Just
See, I was able to explain this one now before the audio stopped. I was able. We talked about it. You guys should read. Anything you don't understand, just put it in the group. I'll make sure to explain with voice notes or video. Because I don't time. Still have things to read. Just read, please. Try to read everyone. I wish everyone the best. I wish you
all
all the
right. Thank
best.
you. Good night, everyone.
Because you know
Amen.
they read,
Thank
now
you.
that's how you the form J one. Because you know they read again. I bet.
Chill out, TikTok.
Now you are
Yeah, I want to
return.
watch movie, Jare. What did you say? I want to watch film. No time to read, Jare.
Things made me calm down now. Wetin happen now?
Now they para. I did the pack C for this exam. This guy did
Don't
everything.
This
forget.
class don't end. Has this class ended?
Yes, so
Yes,
class
bro.
has ended.
Now